मेरे प्यारे बच्चों, आज हम फिर बात करेंगे टॉपिक हाइड्रोस्टैटिक्स से रिलेटेड कुछ सब टॉपिक्स के बारे में। उसमें पहला है मेजरमेंट ऑफ हाइड्रोस्टैटिक प्रेशर। A sample device used to measure the hydrostatic pressure is shown in figure. Here C is an evacuated cylindrical chamber of a matter having an airtight frictionless piston P, which can slide inside the chamber. C. S is a metallic spring of non-spring constant. Its one end is connected to piston and other end to the inner bottom face of chamber. This device is placed at a location inside the liquid where pressure due to liquid is to be measured. The force due to liquid presses the piston downwards. The spring gets compressed. A restoring force comes into play in a spring which will try to take the piston back in equilibrium. Piston, the inward force F on the piston due to the liquid becomes equal to the outward spring force is equal to Kx, where x is compression of the spring and K is the spring constant or spring. If A is the if If A is the area of cross section, area of cross section of the piston, then average pressure due to liquid at a location is P average is equal to F upon A is equal to Kx upon A can be measured. The liquid at rest exerts equal pressure in all directions at a point inside the liquid. Point number 12. The liquid at rest exerts equal pressure in all those points which are in one level inside the liquid. Point 3. Liquid pressure is independent of shape of the liquid surface as well as area of the liquid surface, but depends upon the height of liquid column. Point number 4. Total pressure at a depth h below the liquid surface is equal to V naught plus h rho g, where P naught is equal to atmospheric pressure. Point number 5. Pressure is a scalar quantity. Point number 6. Mean pressure on the walls of a beaker containing liquid up to height h is equal to h rho g by 2, where rho is the density of liquid. Point number 7. Thrust exerted by liquid on the walls of the vessel in contact with liquid is normally to the surface of the vessel. Some application. Some applications of the concept of pressure. The concept of pressure. First है the bags and suitcase are provided with broad handles so that a small pressure is exerted on the hand while carrying them. Second, railway tracks are laid on large size wooden, iron or cement sleepers so that the thrust due to the weight of train is spread over a large area. This reduces the pressure on ground which would prevent the yielding of ground. Point number 3. It is painful to walk barefooted on a road covered with edge pebbles. It is due to the fact that if our body weight is supported on a very small area of the sharp edge of the pebble on the road, it will exert in reaction a large pressure on our foot. Point number 4. It is difficult to walk barefooted on a sandy ground as the sand yields under our weight. This difficulty can be overcome by spreading the wooden board on the sand. In this situation, the thrust on the sand due to our weight will get spread over the whole area of the board and hence a very small pressure exerted on the sand. Due to it, the sand does not yield. Point number 5. Pins and nails are made to have pointed ends in order to have least area of contact between the pin and the given surface. Due to it, the pin of priest will exert high pressure on the surface and hence will easily penetrate the surface. Density and relative density. Density of a substance density of a substance is defined as the mass per unit volume of the substance reduced density rho equal to mass m upon volume v. Rho is equal to m upon v. SI unit kilogram meter inverse 3 CGS unit gram centimeter cube inverse 3 dimensional formula m1 l minus 3. Positive scalar quantity तो डेंसिटी क्या है, पॉजिटिव स्केलर क्वांटिटी है। A solid or liquid is generally incompressible. Its density remains constant at all pressure. The gases are generally compressible. Their density vary with pressure. The density of water at 4 degrees Celsius is equal to 277 Kelvin is 1.0 into 10 to the power 3 kilogram meter minus 3. Relative density of a substance is defined as the ratio of its density to the density of water at 4 degrees Celsius. It has relative density is equal to density of substance upon density of water at 4 degrees Celsius. Relative density has no units and no dimension. It is a positive scalar quantity. The relative density of aluminum is 2.7. It means the density of aluminum is 2.7 into 10 to the 7 kilogram per meter cube. Next, relative density. Relative density of a substance is defined as the ratio of its density to the density of water at 4 degrees Celsius. It has relative density is equal to density of substance of density of water at 4 degrees Celsius. No units, no dimensions, no dimensions, positive scalar quantity